Imagine harnessing the natural flow of water to light up cities, power industries, and sustain millions of homes. Welcome to the world of hydroelectric power. This ingenious method of generating electricity has been at the heart of renewable energy for over a century. From the simple water wheels of ancient times to the colossal dams of today, the utilization of water's power has evolved dramatically. As the world grapples with an increasing demand for energy and the pressing need to reduce carbon emissions, hydroelectric power stands as a beacon of hope. This renewable energy source leverages the kinetic energy of flowing or falling water, converting it into electricity that powers our lives. Quietly, tirelessly, and with minimal environmental footprint, the water cycle fuels this continuous process. A marvel of engineering and a testament to human ingenuity, hydroelectric power has been part of our energy solutions for centuries. It's a clear reminder of how we can coexist with nature in a mutually beneficial relationship. Now you might wonder, how does water create electricity? It's all about understanding the basic principles of hydroelectricity generation. The magic begins with the flow of water. This is typically facilitated by a dam that stores water in a reservoir. When released, the water rushes down a pipeline known as a penstock, guided by the force of gravity. As the water surges down the penstock, it encounters a crucial player in this energy transformation dance: the turbine. The turbine is essentially a large wheel fitted with numerous blades. When the rushing water hits these blades, it causes the turbine to spin. This rotation is the first step towards generating electricity. But how does a spinning turbine create electricity, you ask? Well, the turbine is connected to a generator, which houses a large magnet and coils of wire. As the turbine spins the magnet, it creates a moving magnetic field. This magnetic field pushes electrons in the wire to move, generating an electric current, and voila! We have electricity. From here, the electricity is sent to a transformer, which increases its voltage, making it ready for transmission over long distances through power lines. But the story doesn't end here. The water used in this process doesn't just disappear. Instead, it is released back into the river or body of water from which it was initially taken, ready to be used again in this renewable cycle. One of the great benefits of hydroelectric power is its positive impact on the environment. Unlike fossil fuels, it doesn't release harmful greenhouse gases. Plus, it's a reliable source of power. As long as the water flows, we can generate electricity. Hydroelectric power is an excellent example of how we can harness the natural forces around us to create clean, renewable energy. By understanding and appreciating this process, we can better see the value in protecting our water resources and investing in renewable energy technologies. Just like that, the unstoppable force of flowing water is transformed into clean, renewable energy. Not all hydroelectric power plants are created equal. They come in different shapes and sizes, each with its unique features. First, let's dive into reservoir hydroelectric plants. These are the giants of the hydroelectric world, featuring large dams that hold back enormous bodies of water. As the water is released, it flows through turbines, generating electricity. The primary advantage of reservoir plants is their ability to store vast amounts of water, which enables them to produce power on demand. Next up are run-of-river plants. These facilities are typically smaller and more environmentally friendly than their reservoir counterparts. Instead of storing water, run-of-river plants use the natural flow of a river or stream to turn their turbines. This means they produce less power, but their impact on local ecosystems is significantly less severe. Last but not least, we have pumped storage plants. These operate a little differently. They consist of two water reservoirs at different elevations. During periods of low electricity demand, excess power from the grid is used to pump water from the lower to the upper reservoir. When demand increases, the stored water is released back down to the lower reservoir, passing through turbines and generating electricity. It's a bit like a rechargeable battery, storing energy for later use. Each of these types of hydroelectric power plants has its unique advantages. Reservoir plants offer high power output and on-demand generation. Run-of-river plants provide a more sustainable option with less environmental impact. Pumped storage plants, on the other hand, excel at balancing the power grid, storing excess energy during off-peak hours, and releasing it during peak demand. But here's the thing to keep in mind. Regardless of their design or size, all these plants share a common mission. They harness the kinetic energy of flowing water, converting it into electricity that powers our homes, businesses, and cities. Despite the differences, they all share a common goal: to convert the kinetic energy of flowing water into electrical energy. As with all energy sources, hydroelectric power has its environmental considerations. It's a delicate balance, you see, between harnessing the raw power of water and preserving the natural ecosystems that thrive around it. While hydroelectric power is indeed renewable and significantly cuts down on greenhouse gas emissions, it is not without its challenges. The creation of large reservoirs for hydroelectric plants, for instance, can disrupt local habitats and alter the course of rivers, affecting both wildlife and human communities. The damming of rivers also raises concerns about water quality, as stagnant water in reservoirs can lead to increased sedimentation and changes in temperature. But let's not forget, these are issues that many dedicated scientists and engineers are tirelessly working to mitigate. Innovations in turbine design, fish ladders, and reservoir management are just a few examples of how we're learning to balance power generation with environmental preservation. While there are challenges, hydroelectric power remains one of the cleanest and most sustainable energy sources available. Hydroelectric power isn't just a theory, it's a global reality. Let's embark on a journey around the world. Our first stop is the Three Gorges Dam in China, the largest hydroelectric power station in the world. With a whopping 22,500 megawatts capacity, it generates an average annual energy output equivalent to burning 40 million tons of coal. We then leap across the Atlantic to Brazil's Itaipu Dam, a monument of international cooperation between Brazil and Paraguay. This engineering marvel generates nearly 95% of Paraguay's electricity and a significant portion of Brazil's, demonstrating the potential of cross-border collaboration in harnessing hydroelectric power. Moving to North America, we find the Grand Coulee Dam, the largest power station in the United States. It's a testament to how hydroelectric power can revolutionize a region, transforming the arid lands of the Columbia Basin into fertile farmland. Lastly, we visit the Inguri Dam in Georgia, the world's highest arch dam. Its unique design minimizes environmental impact while maximizing power generation, showing us that hydroelectric plants can harmonize with nature. These landmarks, among many others, showcase the incredible potential of water as a renewable source of power. They highlight the critical role of hydroelectric power in our global energy grid, illuminating the path towards a sustainable future. From the towering dams to the hidden run-of-river plants, hydroelectric power is a crucial part of the world's energy landscape. As technology evolves, so too does our ability to harness the power of water. The future of hydroelectric power is not just about maintaining the status quo, it's about revolutionizing the way we generate electricity from water. Emerging technologies are set to increase the efficiency of hydroelectric power plants. Advancements in turbine design, for example, are reducing water waste, enhancing energy output, and shrinking the ecological footprint of these facilities. Furthermore, improvements in equipment durability are extending the lifespan of hydroelectric infrastructure, making it a more cost-effective solution in the long run. In addition to technological advancements, innovative approaches to harnessing hydroelectric power are also on the horizon. Concepts like small-scale or micro-hydro systems are gaining traction. These systems are designed to generate power from small streams and rivers, making hydroelectric power more accessible to remote and rural communities. Significant research is also being conducted into the potential of tidal and wave energy, a form of hydroelectric power that could provide a constant and predictable source of renewable energy, taking advantage of the vast power of our oceans. The environmental impact of hydroelectric power is also a focal point for future innovation. Scientists and engineers are tirelessly working on ways to minimize habitat disruption and water quality issues associated with hydroelectric power plants. With these advancements, the future of hydroelectric power looks brighter than ever. Hydroelectric power, a renewable energy source that's been with us since the dawn of the industrial age, remains vital in our quest for a sustainable energy future. Harnessing the might of water, we've transformed landscapes and powered nations. From the basic principles of water flow and turbine rotation to the generation of electricity, hydroelectricity is a testament to human ingenuity. We've explored the diverse forms of hydroelectric power plants, each with its unique features and advantages, and discussed their environmental impact, balancing our need for power with the preservation of our planet. Notable hydroelectric landmarks across the globe demonstrate the widespread use of this form of energy, and emerging trends promise greater efficiency and reduced environmental impact. The future of hydroelectric power is promising, and the potential is immense. It's a journey of innovation and commitment to renewable energy sources. So, the next time you switch on a light or charge your phone, remember, the power of water could be behind it all. Thank you for joining us on this journey through the world of hydroelectric power. We are grateful to our sources for their invaluable contributions to this exploration. For those who wish to dive deeper into this fascinating subject, we have provided links to additional resources. Remember, knowledge is power, and in this case, that power can help us harness the awesome might of water for a cleaner, greener world. Keep exploring, keep learning, and let's work together for a sustainable energy future.